So far, we have seen how explicitly create thread and manage thread using libraries like pthreads. But as applications grow to have hundreds or even thousands of threads, this manual management becomes very difficult. Today, we'll explore more a modern solution which is known as implicit threading. So, what is basically implicit trading? The main idea behind implicit trading is to shift the burden of thread creation and management from the user application programmer to the compilers and runtime libraries. Instead of writing code to create, manage, and join threads, the programmer simply defines tasks, usually written as functions, that can run in parallel. The library then handles all the low-level details of how many threads to create, how to assign tasks to them, and how to manage their life cycles. This is a growing trend because it makes developing correct and efficient parallel programs much easier. We are going to focus on one of the most common methods of implicit threading known as thread pools. So, what is a thread pool? The general idea is to create a number of threads at the start of the program and place them in a pool where they sit and wait for work. Think of a web server. Instead of creating a brand new thread for every single client request that comes in, which can be inefficient, the server can just grab an ideal thread from the pool to handle the request. If all threads in the pool are busy, the request is queued up until a thread becomes free. Once a thread finishes its task, it does not get destroyed, it just returns to the pool, ready for more work. This approach has several key advantages. It's usually faster. Servicing a request with an existing waiting thread is faster than the overhead of creating a new one from the scratch every time. It limits the number of threads. By setting the size of the pool, you put a bound on the number of active threads in your application. This is crucial because an unlimited number of threads could exhaust the system resources like CPU time and memory. It also separates the task from its execution. This allows for more flexible scheduling strategies. For example, you could schedule a task to run periodically or after a certain time delay, and the thread pool will handle the execution when the time comes. So this slide also shows a snippet of the Windows API for using a thread pool, where you define a pull function that will be executed by a thread from the pool. Thread pools are powerful and efficient way to manage concurrent tasks without getting bogged down in the details of thread management. In in this video, we'll cover some important issues, potential pitfalls you need to be aware of when programming with threads. So in the Unix-like systems, the fork system call is used to create a new process by duplicating an existing one. This raises a crucial question in the multi-threaded program. If one thread calls fork, does does the new process duplicates all the threads, or is the new process single-threaded, containing only a single copy of thread that called the fork function? So it actually depends. Some Unix systems have chosen to provide two versions of forks to handle both scenarios. The choice of which one to use depends on the new process is going to do. If the new process is going to immediately call the exec function, which replaces the entire process with new program, then there is no need to duplicate all the threads. In that case, duplicating only the calling thread is more than enough. However, if the new process is going to continue executing without calling exec function, then it should duplicate all the threads to continue the multi-threaded logic of the parent. So thread cancellation is the task of terminating a thread before it has completed. For example, you might have a multiple threads searching a database. Once one thread finds the result, you can cancel the rest. The thread to be cancelled is called the target thread. There are two general approaches to do this cancellation. So one is asynchronous cancellation. So asynchronous cancellation is basically one thread immediately terminates the targeted thread. This can be very dangerous. The issue is that the target thread might be in the middle of updating shared data or may have allocated resources that it hasn't had the chance to release. This can leave your application in an inconsistent state. Another is known as deferred cancellation. This is basically a safer approach than the previous one. So the target thread periodically checks a flag to see if it should be cancelled. This allows the thread to reach a set point, what's known as the cancellation point, where it can clean up after itself and terminate in an orderly fashion. Because of the risk, deferred cancellation is almost always preferred.